Okay, Assalamualaikum warahmatullahi and good morning all. Okay, all right, for second and final SPSS lesson, I'll be covering for you today the non-parametric tests, namely involving Mann-Whitney-U, Wilcoxon tests, and of course the Kruskal-Wallis. Now, before we begin, non-parametric tests are usually done when your data is not normal, meaning prior to that, when you do check for normality, the criteria is you have to look at the skewness and kurtosis value based on the sample of your study. Okay? If it's below 50, the Z value for skewness and kurtosis should be between negative 1.96 to positive 1.96. If it's in between 50 and 300, the value is more acceptable at between negative 3.29 to positive 3.29, and larger samples than 300 would accept absolute skewness value between negative 2 to 2 or negative 7 to 7. And another criteria besides skewness and kurtosis is we look at the Kolmogorov, Simirov, and Safirov test results. Okay. Once we do the normality test, if we do not fill these requirements, but you still want to compare means between group as part of your research objectives, you still can do that, but you will have to do the non-parametric way, which are these three. The Mann-Whitney-U is basically a counterpart to the independent t-test. The Wilcoxon test is the counterpart to the paired t-test, while the Kruskal-Wallis is the counterpart to the one-way ANOVA, right? Okay, first let's switch to our SPSS slide, and I will demonstrate you how to run the Mann-Whitney analysis. Okay. So the Mann-Whitney, like I said before, is the counterpart, the non-parametric counterpart for other independent t-tests. And for independent t-tests, we can only compare between two groups. Based on this survey, the only relevant group that has two will be male and female. Okay. But if you do other studies, you may have another variable besides gender. Maybe you would like to compare between the preference of seafood between people in Kota Baru or Kuala Terengganu. So you have two groups, Kuala Terengganu versus Kota Baru. Or in a simple case, since this group has 90 people, K1 and K2, we can you can also do means comparison between, let's say, yes, the acceptance of ready-to-eat food, the perceptions score between those in K1 and those from K2. Okay, so there is just other examples besides gender when you can do the Mann-Whitney or the non-parametric independent t-test. Okay, so to do the analysis, go to Analyze. The non-parametric test is in this section. Go to Legacy Dialogues and click two independent samples. As you can see here, I've already reset it, but for the sake of demonstration, I will reset it. Put gender in here, and we need to define the group. 1 is male and 2 is female. We'll click on our three variables that we want to compare. Let's say we want to compare male and female scores different between the attitude towards frozen food, the attitude of usage, and are there any differences in behavior intention among males and females. So we put them in the test variables. Okay, maybe we want to see the descriptive. We can choose descriptives. Click OK. So this will be the output. Now, the main information, important information from the analysis will be, okay, let's look at the attitude for frozen food first. Are your male and female? What are the mean rank? Then go into the second table. The important information we need are the Mann-Whitney U score, the Z statistic value, and of course the P value. So in this case, the value is above 0.5. It means that automatically there is no significant difference between male and female towards the score of frozen ready-to-eat food. And the same can also be said for the attitude towards the usage of frozen ready-to-eat foods, and also the behavior intention. So let's see how we can report this. Okay, as you can see on the screen here, the topmost column lists down the variables that you compare the means. Second column is the first group, in this case is male. And then the third column will be the second group that we measured, the females. Third, we take the Mann-Whitney score. Following that is the standardized test statistic score, which is the Z value. And lastly is the P value. Compile this in one table. And this is how we interpreted it. Okay. The mean rank for male is 48.33, in bracket 6 respondents, meaning 6 male, while the rank for female equals to 45.26, and the N number is 84, the Mann-Whitney score, and the standard, and then the Z score of negative 0.324. So our statistical decision is we do not reject the null hypothesis because the value is above 0.5. So we can conclude by saying that there is no significant difference between male, state the mean rank score and the number, and females, also the same thing. There are no significant difference between male and females pertaining to their score of attitude towards frozen ready-to-eat food. And then you report the P value, the Mann-Whitney value, and the Z value, or the Z value. Okay. The same principle is applied when you report for attitude towards the usage of frozen ready-to-eat food, as well as behavior intention. Okay. Okay. So what happens if the results are statistically different? All you need to do is report which group has the higher or the lower mean rank, and then followed by the value of the P, the Mann-Whitney, and of course the Z value. For more information, you can click on this YouTube link on how to report for Mann-Whitney, the Mann-Whitney U tests. Okay guys, this is the video link about how to interpret the result of Mann-Whitney U.
When you run a Mann-Whitney test in SPSS, the default display is quite minimal. The significance level for the test is less than alpha, which has been set at 0.05 by default. And the males have a higher mean of 2.547 value, which is 101. Academic levels of the male.
So this is basically how you report it. You can see the video if you want further explanation, but just remark here. This fella did use a different function in SPSS to calculate the result. He actually went, let me show you. SPSS. Okay, here it is. Okay, this guy actually went. Let's see, oops, sticks to the and use. He went and used this function, the independent samples. You can also conduct your Kruskal-Wallis, your man-Whitney and Kruskal-Wallis to this function, but fortunately, my version of SPSS 18 cannot run it. Let me show you. Take gender. If I choose man-Whitney, it comes up with an error message. So that guy in the video used this function, but if you are using the version 18, you may not be able to run this analysis. Okay, but for those who have a different version, can also use the independent sample of, to calculate the man-Whitney and Kruskal-Wallis score. Okay. Those who can should use the normal legacy dialogues option here. Okay. All right. Okay. So the second demonstration will be about the Wilcoxon paired test, and this is basically the non-parametric version of the paired t-test. But if you notice in this survey, it is only done once. There's no question asking how's your opinion before eating ready-to-eat food versus your opinion after you eat ready-to-eat food. But doesn't matter. Kita buat dia. Kita cipta another data set. As you can see here, after behavior intention, I've created a data list of perception scores before buying ready-to-eat food and after buying ready-to-eat food. If you're wondering where I copy paste, I just took frozen food scores, attitudes towards frozen ready-to-eat food scores, and pasted here, while the second is taken from behavior intention, copy paste into this column, and then I rename it here as before and after, before buying and after buying. All right, with that explanation done, let's see how the Wilcoxon test is being done and how to report it. Okay, we go to legacy dialogues, and the Wilcoxon test can be found in the two related samples. Okay, I've already inserted, but never mind, let's reset. So variable 1 will be before buying, and variable 2 will be after buying. Click the Wilcoxon options. You can see the descriptive if you want to, and click OK. All right. Judging from the descriptive alone, we can see that before the mean, before this group buys ready-to-eat food is higher than after they buy frozen ready-to-eat food. Okay, the important value to report here are the mean ranks value. The negative ranks represent the score before, and the positive rank represents after. So there's actually, so it reflects the mean score in the descriptive, in which that perception towards ready-to-eat food is higher before purchase than the perception after you've purchased and consumed it. Okay, another important value you should see and report here is the Z value as well as the P value, which is very, very small, 0.0, below 0.001, which shows the scores before and after are significantly different. So with this, the mean ranks, Z score value and P value are in mind. Let's see how we can report this. Okay, the Wilcoxon test. All right, similarly, what are the variables? The variables are the perception scores before purchase and after purchase. Only the difference between paired t-test is we report the means rank. In this case, the mean rank for before is higher than after, then the Z value as well as the P value should be less than 0.001. Okay. So the statistical decision would be the null hypothesis is rejected as the p-value is below 0.001. In this case, perception of students in K1 and K2 the bachelor's degree in food technology towards ready-to-eat food differs before and after the purchase. So we can report this as the mean between before purchase and after purchase of frozen ready-to-eat food are statistically different. It is observed that the main ranks for before purchase and ready-to-eat food is higher compared to after purchase ready-to-eat frozen food. Another way you can, maybe another sentence you can add that it shows that students in this food technology students have a higher perception could be due to the attractive packaging of the frozen ready-to-eat food. But upon opening the box, cooking, reheating it, and consuming it, they find that the appearance is not as attractive on the box, or they find that the taste just doesn't taste good. So that's why the perception after purchasing and consuming ready-to-eat food is lower after they consume it as compared to before they consume the ready-to-eat food. Okay. Okay. For the third and final analysis, I will be demonstrating how we can do the Kruskal-Wallis or the non-parametric ANOVA. Okay. If you have a working version of SPSS, you can also access it to the independent samples, but I will be demonstrating using the legacy functions. Okay. The Kruskal-Wallis is under this one, K independent samples. All right. bringing our test variables as the attitude frozen, attitude usage, and behavior intention. So the grouping variable, let's choose something that has more than 3 groups. Let's say anggaran pendapatan. For this variable, there are total 6 groups, so we'll define them as 1 until 6. Click on the Kruskal-Wallis. Click on descriptive. Click OK. And run. Okay. Alright, the most important result will be the one in the second table, the chi-square value, the DF value as well as the P value. Okay, this is one way you can report the Kruskal-Wallis analysis. Okay, list down the variables and the difference between groups, the chi-square value, and the level of significance of the P value. Okay. Now let's report the scores for attitude towards frozen ready-to-eat food. You can report here that the Kruskal-Wallis test indicate that there was no statistically significant difference between income group and attitudes towards frozen food score. The chi-square value in bracket, DF value of 5, number of respondent 90, the chi-square value of 3.412 and a p-value of 0.637. Okay. If you wish to report the attitude of usage and behavior intention, just change the value. Okay. All right. And take note, similar to ANOVA, if there is no significant difference between all the groups, there is no need to do a post hoc test. Okay. Right. But if you somehow get a significant difference between some of the groups, maybe a significant difference between, let's say, those earning less than 1,500 against those who earn about 2,000, you can report that and run the post hoc. Okay. Since I can't show you how to do it in SPSS, this video that I've listed here.
In this video I'm going to show you how to perform a Kruskal-Wallis H test. I won't go much into now in that.
Okay,
Select
it is
custom,
analysis,
the test fields. Then click on setting. The teacher was a
researcher used
tab using the newer
the independent sample.
Okay. Click on the fields tab. Select the variable on which you want to split the data on, in this case the location of the student, and move that to the group section.
Get the groups,
the variable
which of the demographic information that has more than 3 groups, you put in the group columns, while in test field, put in the score that you wish to do to compare means.
Which you want to look into where there are any differences. In this case, the teacher was able to motivate me. Move that to the test fields. Then click on settings, select customize tests, and then check the Kruskal-Wallis one-way ANOVA K samples. And then click on run. Now in the output, we immediately see to reject a null hypothesis based on a 0.05 significance level, because our significance is actually 0.000. So that means it's very low, and there seems to be some kind of influence of the location on the motivation by the teacher. Double click on this output and you will actually get something known as the model viewer. Here on the left you will actually see the long list if you have had multiple variables in one go, and on the right then for each of those the results. So you can, if you have multiple, you can click on one of them and then the results for that one will appear here. There were 54 participants. The test statistics is around 21. The degrees of freedom is 2 because we had 3 categories, -1 is 2, and again the significance is shown. Note that the test statistic is actually adjusted for types. Now under view you can actually select pairwise comparison.
Okay, if you want to find which the group which is significant, you will have go into the view and choose pairwise comparison, as demonstrated here.
And you will then actually see which
and
of
the table will be
groups
generated
were
here.
actually significantly different from each other.
Which
In my
group are
case,
different?
look for the adjusted significance. It's adjusted by Bonferroni correction. Rotterdam and Diemen are significantly different from each other. Haarlem and Diemen are significantly different from each other. And Rotterdam and Haarlem are not. Now to see which one ranked highest, we can simply look at these numbers next to each of the locations in this case. And these are the average ranks or mean ranks. And we can see that it's the highest for Diemen and the lowest for Rotterdam, and Haarlem was in between. So Diemen is significantly different from the other two, but these two were not significantly different from each other. Now a high rank is not necessarily a good thing. You need to check how it's actually coded. So remember that Diemen had the highest rank, but let's check in the data. So I'll go back to my data file, into the variable view, scroll down to the variable that I was using, and in this case 1 was fully disagree and 5 was fully agree. So a high average rank would mean that they're more towards the higher value here. So if this would have been coded the other way around, then so that 5 would have been fully disagree, then a high, in this case it isn't, it's 1 and the other number that it's not, you might be able to. So
Okay.
So if this
So to
was
conclude, if you wish
in the
to
data, so I'll go back different from each other. Now a
to
high
view which groups are significant, you will have to look at this table here. Because similarly to how the post hoc in ANOVA is done, the Kusko-Wallis version will appear in this table here. So there are significant difference between income groups. Just extract the information from this table and report it as significant and which group are significant. Okay. All right. With that, I've come to the end of the class for this week. Okay. Hope you at least learn something. You may not use it in your analysis when you do beta or within your master's or PhD, but at least you know that you have an option of analysis in the event that your data is not normal. Okay. So if there are any questions you would like to ask me about this week's class, you may feel free to contact me and I will try my best to respond. And for end the class, I end the class here with thank you very much for listening and Assalamualaikum warahmatullahi wabarakatuh.